This will probably be a bit bigger movie, but it will be worth it. First of all, before I start or in a very short description, I will say that this is a device for de-isolating wires, copper wires, this kind of wires, to remove the isolation, the red isolation that you see there, and to leave the naked metal to be soldered with this solder and then linked with in my circuits. So this is this apparatus that is doing its purpose. But now I will start from the beginning. When I took out this motor from my motor box, there I have a box full of motors of any shape. It's not a big box, but I have plenty of them. And this motor didn't actually work. I had to repair it. And inside it, this is it's the lid that is like this here, and inside I discovered a very weird, for me, I never see this kind of circuit or components that he is having. I hope you can see clear enough. This is a capacitor here, the blue one. This is a coil on a ferrite core, and this is another capacitor here, fixed. Both of them are fixed capacitors, and coil or winding on a ferrite core, and that's it. These three components, and the rest are the pads, metal pads, and also wire connections that are, you can barely see it, but I will describe it to you. So when I first open it up, 1 second, pizda mati. So when I first opened it up, it had this capacitor that I put it aside. I preserve it, and if you can see, it is totally burned, is scorched. It's absolutely burned, and it is. I tested it with a continuity multimeter, and it is conducting from one side to another. So I immediately realized that is the faulty component, and I actually I searched in all my capacitors that I have, and I took out something that was resembling as a shape and form to this one, to the original one, and I find this blue guy, but I'm not sure of the value. I've only managed to read this was plus 35 volts. It says it was written on it, and this is plus 50 volts, which is better. But I'm not sure the value, because this was scorched. The value was erased by the black thing, and this was, I'm not sure, something like I have here on my capacitors there, 100 nanofarads, in that range, actually, from 100 nanofarads to 1 microfarad. So it's I'm not sure. Let's see if I can see. No, I don't. Probably 500, 200, I don't know. I'm not sure nanofarads. I'm not sure what value it is. But I installed it, I mounted it, and it worked. That's it. And actually, for a few seconds, immediately after I put it, when I closed everything and I made the contacts, it got a burst of white smoke from somewhere. I'm not sure from where, I'm not seeing any damage to the coil itself. The coil itself is very clean. It's very good actually, and is not giving any signs of any burn. So it must have been this guy again, or maybe or maybe it was this guy, but my memory is fucked up. But if I remember right, I believe I got a white smoke, very white smoke, very white, and very even right now is smelling a little bit from that period when it burst. No flames, only smoke. I immediately took out the electricity from it, and when I plug it in again, it worked. And it worked from sense. From that point on, it worked absolutely fine. I'm not sure what it was. Probably a very short. Probably a short, some wire. By the way, this let me describe how this circuit is. If I can film it with one hand. Like this somehow. Let's see. Here is a contact here. By the way, this is one single wire, but inside is two wires. So one wire is here, and another wire is here. And you can see a white thing, plastic. There, that is the isolation, and this is the other wire. So these two wires are coming from that wire, blue wire, external, and are made in connection to this capacitor here, and this guy, another wire here to this coil, and from this coil is going to this pad, this large pad. From this large pad is one connection here from this capacitor and going to this pad from the capacitor. And this pad is connected to this point here, which is the other wire. And between the between the two wires is this guy, this capacitor. It's probably behaving like a fuse. For sure, it behaved like a fuse in the moment when it smoked. But yeah. I didn't test it, I didn't check it. Maybe it's totally burned inside, I'm not sure. But the state how is this guy here, I'm not sure. Okay, this is it for this. So another detail here. This is having some very strange head. So I took out the plastic a little bit to see inside. What is doing actually is doing this. This is doing is a very you see, it's a spring. That's it. On one side and on the other side it is exactly the same thing. It's doing this spring is like I have no fucking idea what it might be. And this is a screw, which you can see it's a screw on both sides, and here is a little bit of paint that is not a marking, that is a sealing. Actually is sealed. It's very it's like a very it's a precision, I believe is I believe my wild guess is all this part here are for calibration to be perfectly centered. I believe this might be it. Very strange little thing. But this is my interpretation of how of what are all these mechanical mechanisms. This is closer. Yeah, it's, I believe is a calibration for centering. the entire thing. Very interesting. Very old, actually. Very extremely old motor. And another very important thing, and this I couldn't repair it. You can see the carbon carbon contacts here. They are totally you see, it's very little remained. You see, I hope you can see. And I search for contacts, and these are very special contacts, and I'm not sure how. My idea is to find another motor and to take out and solder from this wire here to there and somehow to repair it. But it is working how it is right now, until it will totally die. I am unable to change those contacts. You can see here it is soldered, so it has a metal inside that is soldered from this part. I didn't desolder it. Yeah, this is shitty. This is very shitty. This motor life will be, it's on its end right now, with this very eaten contacts that it has there. But yeah, if someone is seeing this this circuit and you know what, actually I've made a test with the motor after I repair it, and I observed something. When I am opening this guy, is showing me, you will see in a moment actually, is showing me the voltage and the amperage. And when I stopped the entire motor, when I pinch it and stop it from here, from the axle, while it was turning, when I stop it like this, or better said, when I slow it down with the force of my fingers, and it was slowing until mostly to be stopped, but it was not stopped. It was very slowly rotating, but in force, a lot of force. The speed remained almost like it was turning normally, and when I let go my fingers, the speed remained pretty much the same. So I believe this circuit, it must have something to do with that, like a feedback, you know. Very interesting motor. I really like it. But here on when I plugged in, when I put this bar here, this heavy bar, metal bar, and the roulement in my language, I'm not sure how. These are including a bit more stress or force to the entire motor, and is actually slowing down, is not maintaining the same speed as much as I'm pressing it. I'm not sure why, but it is slowing down as long as I'm pressing, inducing some force there. But when it was without all this stuff that I put there, it did behave like I'm describing it right now. Very interesting. I really like it, and I'm really happy that I managed to repair it and make it work. So now I will assemble it again, and I will present next the electronic circuit that I made, the variable speed circuit, and see you in a second, I suppose. All right, now it's back together, and it has one screw here and a second screw there, and that's it. Only two screws. And this way was very easy to assemble and disassemble. I was very sure I will have to get it out from these things, but yeah, I managed to. to put it to mount it back, and here it is, working back as it should. And you can see it's working pretty good, at least the variable speed that I'm giving it from here. And as you can observe, the rotation is extremely slow and very fast, switching between off and on state, and it's almost rotating, it's barely rotating, and it's making the switch very fast. But I can manage to variate the speed a little bit, but it's so sensitive. It's so fast. Is when I'm rotating it half of 1 degree, so 0.5 degree or 1 single degree, if I'm rotating it, that's it. It's on off. It's extremely sensitive. If I'm putting this is 1 kilopot, but if I'm putting 10 kilopot, it's more sensitive. I have to rotate it 0.3 or 2. The range is, and the angle is very shortening extremely. No, it's the best thing is to put here 500 ohms, lower value than 1 kilo, to have a little bit of more range. But I'm not sure how much range I will actually have. But yeah, that's a detail. In a sense, I have two switches on off. One switch is from here, if I'm rotating it this side, from the middle, and from the middle to this side is maximum on, and this is off. And this is one switch, and this is the second switch that is toggling on off like that. And yeah, but if I want to preserve the speed that I have the toggle here. All right, I literally scrapped everything I find, and I made it from scraps. This is a small bearing. I believe it was 0.5 centimeters, so 5 millimeters inside, and this is 6 millimeter stock actually. So this is and I machine it to fit there in that roulement bearing. That was not working as well. That was stuck. It had a lot of dirt, and what I did, I can show you actually. I used my lathe here, and I put the bearing there. I from the middle I put a screw, and I kept the middle stationary, and the outside was rotating, and I bring it to 2500, because this is set to maximum here. So, and this is the middle point, 1700. And I did this, and I kept it there a couple 1 minute or so, and the idea was that I was obliterating and making everything that it had in there either flow away, or make it as like a dust, to make it powder. Actually, I wanted to make it powder, whatever it had in there. Also, I've put oil in it, a lot of oil actually, and then I put it to rotate in my lathe there, in my chuck of the lathe, and that solved a lot of problems actually, because this roulement was impeding. It was putting a lot of force to the axis of this thing, and it was not working properly. So that's that was a solution, and now it's pretty smooth, almost like new. Not perfectly like new, but pretty close. All right. Next thing is the circuit itself, the variable circuit. Because this is a strange motor, I never seen that circuit inside on any other motor. I didn't open that many motors in my life, but from what I know, usually it has all those contacts, and that's it, directly on the wires, without any capacitors or an additional inductor there. But I never seen that kind of circuit ever. I'm not sure what that does. I presume maybe that is some sort of feedback to keep the same speed, but for the rotor. I'm not sure. But usually it's much more simpler and much more straightforward. The contacts inside to the rotor. That's what I wanted to say. So this was a special motor for me, at least. And I did initially. This actually is a 5-minute circuit you can build, and I did exactly that. I built a first, let me find which one, this one it was. I put an LED, a resistor, a 10 kilo resistor, an LED and a potentiometer, and one NPN transistor. What was that? BD 139. And here is the pins. And this is the motor. I put a diode to. Actually, that diode I don't have it right now there, because that diode, I suspected this was the diode actually that I put it. That diode made the things worse. I had a lot of bad luck. I had to tweak it until it worked. This circuit, it took me 3 days instead of 1 hour. It took me 3 days to make it, and it didn't work. The NPN transistor, the BD was 139. Got extremely hot, extremely hot, and I suspect that diode was. I'm not sure. I had a lot of bad luck. Then I said, well, I should make another circuit with two transistors. This guy here was the BD Nova 139, and this was another NPN but smaller. I'm not sure. 222, 2N 222, or but those small transistors. And this didn't work at all. I'm not sure if something got hot, but it didn't work. The motor didn't spin at all. So I switched to MOSFETs. So these are BJT. This is the actual circuit. This is the first circuit, and it's what you are seeing there actually. I made it with one the first time, then with the second, the smaller transistor here, and all this diagram that you see, all this connection that you are seeing here, are actually made on top of the first one, but for the second with the two transistors. But initially I made it for one transistor here, and then I've added a second one and made those connection, and it didn't work as that as well. And everything you can see is literally scorched. Everything is scorched. There is burned out. It's because I took it out, I put it in. Is looking very black there because I'm using this thinner. I forget how it's called. Sakız is called in my language, but I'm not sure. I don't remember exactly the name in English. But I'm using that to liquefy and help the solder get everywhere, pretty much, to stick better to the metal pads that I have there. And this black thing actually is not black, is yellow, very transparent yellow, but it got burned here. So when it's getting burned, is getting black. That's why is like that. It's used for violins when you put on the strings of the violin, or any string instrument, musical instrument, you know, you wipe it with this substance, and the thing is working better. Whatever, I'm not a musician, so I'm a painter. I'm on the other side of the fence of the art. All right, so this is with the MOSFET. But before I tried this big MOSFET that you see right now that is working with it, I've actually tried this guy here, this MOSFET, and its characteristics. I've read every datasheet beforehand, and this should have worked, but it didn't. It got extremely hot very quickly, and I closed the experiment, and I actually made a special board for it, this guy, but it did a very straightforward board, but it didn't work. It got extremely hot very quickly, so I had to throw it away. And I've tested this big boy here, which is also a SMD semi-D component, and this guy, yeah, it was the winner. It really had to be a big MOSFET to drive this pretentious motor that I have here. Here are the tests after it was working. I made some tests at 3 volts initially, and then I switched to 5 volts. And while it was rotating, this helped me a ton. It helped me. I was watching the amperage, the current display there. Actually I can show you right now on maximum. So these are the values for the maximum speed. So right now it's 30-28 something. It's fluctuating for some reason. And this is what you are seeing here. Is for 5 volts I have maximum of 320 milliamps for 5 volts, and for 3 volts I had 280 milliamps. So it's actually very good that it's staying at 280 like it was for 3 volts, but now it's on 5 volts, and it's very good that it's staying on 280. But when I'm installing it, you can see there, if I'm installing it, if it's in power and I do this, it's going up to 540, which is absolutely amazing. But I believe is that power is dissipated by this transistor, I believe, this time. But I did all this information gathering here while I was connecting it directly without this circuit here, and when I got all these values. So for 3 volts I got 450, almost 500, like you've seen, and for 5 volts I got 840, which was quite big value, because it's almost 1 ampere there. And the way this is functioning, my skin is getting thinner right now. The way it's getting is functioning, let me is that, actually let me stop it and see. This is a metal rod, as you already know, and this is let me actually show you. I hope I have. Yeah, 240 what is called scratching paper. So I use this sandpaper. Wait. So I used this sandpaper, 240 grit. Here I roll it, and I used a glue, a simple glue. Here, this guy, the yellow guy, which is used for papers, to stick papers, but it's extraordinary strong glue. I knew it, and it's kind of fast. I leave it like 1 hour probably, and also to get this. This was actually a problem here. Not this gap, not gap, but this close connection that I from one side to another, I had to trim it with the scissors until it get right, and also it had to be glued very well, especially on these sides, both sides. So for that, to be certain it will get flush leveled with the cylinder, I used this a simple string of wire, sewing wire, and I do it. I make it like that, and it actually hold everything extremely well, and it pressed everything and keep it there while the glue was hardening. And voila, right now when I took it out, I was expecting actually to peel out after I took it out, but it didn't. And yeah, I'm very happy for this. If you are wondering what are these 2 screws here, these are to catch the internal the axe of the motor. The axe of the motor is entering in a hole in this cylinder here, metal cylinder, and I drilled and tapped 3mm screws, holes for the 3mm screws, and this is the more like a balance, not balance, is getting the right height, the smaller one, and this bigger one is actually screwing and keeping and pressing, pressing everything. That's the top one. I have a problem actually. As you can see here, I made this special plug here, which is actually having a very funny story by itself. I will tell it very quickly. This is actually a jumper, and this here is actually the interior of that jumper. This is how is looking that jumper inside. So it's pretty much shortened, you know, and you cannot put two wires because they will get shortened. So I had to make my own contacts. I bent them and took it out long enough, and then I squeeze inside some plastic, as you can see here, from this side, and then from the other side, from the bottom here, and then I was making sure it's actually getting inside these pins I have here, if you can see them, these two pins here, this and this, and and then I put a lot of plastic here on the naked metal wires, because it was the problem of it was the risk of touching each other. So I isolated further up. So that's why it's looking like this. But the problem that I had, getting back to the thing, is if I'm reversing the polarity, the motor will spin in the other sense. That's why the reason and the trouble to make this little contactor here, plug here. So if I'm inverting the plug, let me do it actually right now, and you will see. I hope I can film it, and right. So let's see. No. It wasn't. Yeah, now. So now is going on in the other direction. But it's a problem, it's a big problem actually. You see? The motor, if I'm doing this, the motor is still spinning right now. You can hear it. Look at the you see? It's spinning free. That means I stop it. That means spindle of the motor is rotating freely inside the hole of this arbor, of this cylinder, metal cylinder that I have here. And this screw is unscrewing every time is in this direction. But if it's in the opposite direction that I originally put it, like this, if it's in this direction, it is screwing and pressing actually, and is not letting escape. The screw is not escaping. Actually, I had this screw got out, and it flew away a couple of times when it was in that direction, and now when it's in this direction, is actually holding, and actually you can see when I'm pressing is actually stopping the spindle. The spindle is actually stopped, is catching somewhere, is catching, but in the other sense it is escaping, is skipping somehow. I'm not sure what is catching here and escaping on the other sense, but it is how it is, and is working. So I had to learn this little thing, a lot of physical problems I had to resolve on it, and a lot of electronical problems I had to overcome. Actually, it took me I believe 1 week, so about 7 days. and it was the transistor problem that I had. That was the most annoying problem that I had, because I was expecting to work from the beginning from with that NPN transistor in the beginning, with BD was to no 139, and it didn't. And when I see that thing, it didn't work. I was so disappointed, because I knew I will have to do it to bring it up to the MOSFET stage like it is right now. This was the plan B. Actually, the MOSFET was plan B. If the plan A with NPN, BJT NPN didn't work with the MOSFET, I was kind of sure it should have worked. I was not completely sure either, but yeah, it was a plan B. I actually had a plan C as well, but I will not tell it because it's stupid. I believe I talked everything that I could. Like I said, I had a lot of big and small problems. The thing is, it took me like 1 week. Like I said, I never give up. I never give up, because I knew in my heart I can make it. Even if I was not very sure how this part will work. Let me actually show you what is doing all this machine, because you've listened until this far, and you deserve to see it in action. If I can, let me I mounted the phone up as usual, and let me make you a test right now what is doing. I hope you can be you are able to see it. So if I'm having this piece of wire here that you can see, I hope you can see it, and I have to desisolate it. Usually, how I was doing it before, I was doing it in 2 ways. The first way is the cleanest and the best way, but is the longer way actually to do it. When I'm scratching it like this, manually, like this, and not everything will get off. All the isolation will not get off, because let me draw it very quickly for you on this piece of paper here. So if this is the wire like this, if this is the wire like this, and you scratch it here, you only get a single a single side, but you have to rotate the entire wire to get all the sides on the back, on the sides, on top, and also on diagonals. And you had to literally switch it back and forth, and sometimes is catching only from here to here, but here is leaving the isolation, and you had to get multiple times with the knife to scribble it and to look to see exactly how well the scratching and the cleaning performed. And it's a lot of time. Trust me, it is taking me like, I don't know, a couple of minutes, 1, 2, 3, depends how fast I'm moving or how lucky I am. Like 2 or 3 minutes for only one single side, and then I have 2 sides to clean up. I have this other side, and again 2 or 3 minutes for this side, or sometimes it took me 5 minutes, and I was so pissed off. And then I have to put it in this solution here with my iron, and then on this solder, and solder the ends of this wire, and is ready to mount it in the circuit. And the second modality, actually I got this is not a powered one, so it's cold right now. Otherwise my skin was sticking literally to the hot iron here. So the method is with something hot to melt this enamel. Is called in my language is called email. Email is called in my language. Some wise dude here in Romania didn't understood the words right, and he interpreted it in his way, and it stuck and it remained like that. But the other some guys from AAC forums, which I highly recommend for someone with that is serious in electronics, to do electronics. So these guys on AAC told me about a creuset or a ball. Actually, it's like this. It's very small, and inside is having this solder. It's like a cup with solder, with melted solder. And you stick this this wire in that melted solder, and you desisolate it. That was their solution. It was a very memorable solution, very smart solution actually. But this is very thick, very good quality actually, extremely good quality isolator for this wire. I really like it, but is a pain in the ass to desisolate it, to take it out. So my heating version experience, I put it like this, and I was scrubbing it, I was rotating it back and forth, and it did kind of make it a bit more faster, and or like this, zack, like I was scraping with the knife. Actually, I was doing it like this a long time, and then I figured it out. I can roll it like this, and also pressing on it. And then I put the what is called the solder. I make it hot, and I inserted it, but that didn't melt completely, at least, or very fast, this isolation, because it's very thick, and it didn't I had to wait like 10 minutes with this hot until that got burned. So it was extremely way more slower than scraping with my trusty knife here. And this was a bit more a faster solution with the hot iron directly here and doing it like this. Sometimes it worked, sometimes it was the wire is so thin, is catching in the wood here, and is not rotating. I was doing it like this, but it was not rotating at all. I had to move it somewhere where I could feel is rotating. Yeah, it was a lot of work, a lot of pain in my ass, and all this project actually started because of this project here. I had a lot of wires here, not counting, but actually I will count. So every wire that I have here, from here to here, 1 wire, 2, 3, 4, 5, 6, 7, 8, and here I didn't put 8 behind this square. And from all these pins here, which are 8 and 8, 16, all these pins are connected with their corresponding wires on the other side. Look how beautiful it is, but how much work I had to do. I worked like a slave. For all that desoldering, the desisolation, that was the hardest part of the thing. Soldering and make it on shape was fun. Actually, I like it. But desoldering it, not desoldering, the desisolating it, the wire desisolation is a pain in my fucking ass, and I really don't like it. And that was the whole reason. And I have to make 8 of this, 8 boards like this I have to make. And that's the main reason I had to break from that project and to start this project, to build it up and to make it work, to make it happen. And let me actually show it how this will perform. And it's pretty good. It's pretty good. I really like it. Let me give it a little bit of speed, not to maximum. And I have to work with two hands actually. Don't stop. I press too fast, and I also have to rotate it. I hope my time is good. It's like down to 20 seconds like this, and it's also more fun to do it with a machine than with manually with the scraping. It's way more fun to do it with a machine. And right now is not perfect. I still miss because I have to rotate the wire, you know. But it is a bit more fun. In the future, probably I'll put something there instead of my finger. And I'm not sure how well you can see. Yeah, you can see. You see? How it's pretty damn good. I really like it. I really like it. Of course, I have to. And on the other side, let me show you the other side as well to make it. And it's a bit more fun to do it like this than doing it yeah, something like this. I have to learn this tool. Yeah, I see, this is perfect. This is absolutely perfect. Let me show it to you. I hope it will let's see. Yeah, I see it. It's absolutely perfect. I have to learn this tool, how to use it properly. It didn't pass the testing stage right now because it's in its beginnings. Time will tell how good and practical this will be. And yeah, it took me like 10 or 20 seconds maximum for both ends. Almost. Let's say 30 seconds for both ends. And it's very quick and also very easy to do it. So that I've thought on this machine for a very long time actually. It wasn't a one day idea, it was multiple times, multiple days thinking and imagining it, and until I start to believe is actually possible to make it myself with the tools that I have and the resources that I have, because we are in capitalism and resources are not good. Also money are not good. I am not working for literally more than 10 years actually. I was a teacher before, but I kind of give up and I stayed home with my father, and that's it. I'm I'm doing what I like. So, but no money, because capitalism is promising you money, but is a lie. In reality nobody has money, and it's more tragic than it was on the other systems than it was that they were before. Yeah, well, what can I say? I can say nothing. It's good only for Americans, but for the rest of the world, like here in this side of Europe where I live, is shit. Is complete shit. And the capitalism that is here in my part is absolutely shit. Is fucked up. Anyway, back to the business, to the thing. This is it. I think I covered everything. If I forget something important to add, I was planning to show you, to explain the circuit that I did here. Actually, I have it a little bit bigger drawn here on this page, and I will present it very quickly. Actually, I will have to compare it with what I have there. I'll put it like this. These two circuits are perfectly the same. Are exactly the same, actually. These two circuits here are exactly the same. I only changed the order. Let me point with my trusty knife here. So the order, here is the lead and its resistor, and here is the lead. There, where my knife is pointing right now, that is the lead, and that is the resistor. A very black thing on a black background that is scorched, but trust me, it's a resistor there. And then here supposed to be a diode, but is working fine without it, and is working better without it. Actually, I had a lot of problem with that diode until I realized I have to take it out and keep it out from the circuit, but I included in the circuit diagram here, just because I will see in the future if I will put the diode back again and test with other diodes, because this diode that I tested, it gave me a lot of errors, and I had a lot of problem and a lot of time wasted, because I believe it was because of it. It just made a lot of shorts for some reason. I'm not sure. Maybe this is, I'm not sure. That's probably a special diode that I scrapped from somewhere. It's perfectly fine. I check it with a multimeter continuity, and it's behaving exactly like a normal diode. But in this circuit is fucking up a lot of things. My transistors, no. I took it out and it's better. It's way more better. I know for sure it must have a diode here. I know for sure. That's why I insisted to include it. But shit happens, you know. And this is the MOSFET, actually, gate, drain, and source, as well as here. And this is the MOSFET, which actually is exactly like is here in the diagram. So actually here, gate, drain, and source in this position. So gate, this track here is the gate. This white wire is going to the middle of the potentiometer there, exactly like in diagram here. And the middle pin is the drain, and the side pin here, the third pin, and this track that you can that I'm pointing with my knife here. This is the source pin of this transistor, and the transistor is staying funky like this because I actually had to weld. This is the drain, and its pin is cut from the factory. It's cut. It's not long, so I made my I put a wire from this side, which is the side is the same as the drain, and it is working fine like that. Here is the switch which is here. I put it on 0 volts, the switch. Usually you should put it on plus side, but I didn't had too much space there, so I had a lot of more space here, because here, like I said, here it was the the second NPN transistor, if you remember, and after I took it out, these pads remained. I didn't took them out as well, so I use them. And so this is the potentiometer, of course, 1 kilo, this guy here. And this is the 0 side, this is the plus side of the potentiometer, and it's there are a couple of wires there. One wire that is going underneath, and one wire that is going here to the actual 0 volts connection, and that's it. This is the circuit. Not that complicated. It should have worked from one go, but it didn't. It should have worked from one try, and it took me 3 days, 7 days. No, the entire project it was 7 days, but the circuit like 3-4 days, only the circuit. And yes, it is already a very long movie. I say thank you for watching, and yeah, leave a like, and goodbye. Thank you very much again, and see you later. Bye.